So these are topics for today basically. So we're going to look at various servers roles, that what are the roles of different components in the Hadoop system, which we discussed briefly yesterday. So yesterday was like mostly theoretical. So today we are going to actually do a real setup. So that's where we'll see a real demo of how different components that we talked about yesterday work. We are going to look at HDFS architecture. We are going to look at MapReduce job execution. And then we are going to look at how a file is written on Hadoop and how do you read a file from Hadoop? How does it actually happen? What's the anatomy? What is rack awareness? Then we are going to do a Hadoop installation. We're going to look at mail Hadoop configuration files. How do you change the parameters there to get a cluster up? And what are the different cluster modes? And then we are going to look at some cluster architecture, how it looks like in production. And then we're also going to look at Hadoop multi-node installation and what are Hadoop clients. So looks like we have a lot to cover today. So let's get started. What are HDFS blocks? So again, we covered this yesterday also, but today we are going to discuss in detail. So whenever a file comes up, a file is always made up of blocks. When you talk of a Unix file system, the block size is really small. But when it comes to Hadoop, the file system would be a big file, and the file would be split into multiple blocks based on the block size of the cluster. So if you define your block size as 64 MB, then any file that comes to a data node, all these blocks will be 64 MB blocks. So if this file was say 128 MB file or 256 MB file, so that means it will have 4 blocks. So this file will be split into 4 blocks, and based on replication, there will be 4 times 3 blocks. So there will be 12 basically blocks for a 4 block file based on the replication factor. If replication factor is 1, you will just have 4 blocks. If replication factor is 3, you will have 3 different, as you can see, there's a blue colored blocks, there are orange colored blocks, and there are green colored blocks. So these basically signify the replication, and these blocks then end up on data nodes based on where name node decides to put the blocks. And the name node basically is now managing the complete file system, as we discussed. So there's a file system image, which is made up of the blocks in the system. All the data nodes basically tell their blocks. Whenever a data node comes up, it will tell its blocks to name node that I have these blocks. So all the blocks, for example, in data node 1, you can see there's blue, red, green colored blocks. So these are the blocks that are on data node 1. Similar, data node 2 has blocks. So whenever data node comes up, it will tell that I have these 5 blocks. So name node will basically make a note that these blocks are on this data node. And then it will have file system image, where it will basically know the file, and it will have the blocks, and from data nodes it will get the block report. So now it will know that which blocks are on which data node, and then that basically that file system image plus this in-memory metadata from data nodes, which tells the block mapping to the data node, tells that name node clearly that where actually a file would be. And then we have something called edit logs. So whenever some change is done on the file system, a file gets removed, a file gets created, then we have edit logs. Like you have bin logs, for example, in MySQL. So based on that, we have these transactional logs, which are called edit logs. So basically, if you want to have the complete file system image at any point of time, what you'll have to do is you have to look at the initial FS image, which is the file system image that when name node came up, and then after that all the changes that happen to the file system, they go under edit log. So if you basically combine file system image and all the edit logs that are present in the name node metadata directory, if you are combine them together, those together combined will tell you the file system state at the point of time, which is now. So basically that's how the file system image is built. So again, we are going to discuss this in detail, but this is basically just telling you that what are basically HDFS blocks, where they are stored, and how name node knows where the blocks are stored. So Sanjay has a question. When a data node goes down, then the block info is removed from the FS image. So FS image basically is the image that came up. Yes. So as I said, there's in-memory file system metadata. So where whatever blocks are there on a data node, they are in name node's memory as a bitmap. So if a data node goes down, the name node will not receive any heartbeat, and then it will basically update those blocks for that data node as stale, and it will basically try to, based on your replication factor, for example it was 3, and then say one data node went down, so all these blocks, the first blue block for example, what is now replicated on 2 nodes only, this and this, the name node will start replicating this block to another node, and once it copies that block to another data node, then it will update that information in his bitmap that now the new data node, third data node for this block, is the new node where it just replicated it. So name node basically takes care of re-replication of the blocks in case a data node goes down. So hopefully that answers your question, Sanjay. And Syed is saying, is the default to 64 MB each blocks? So yes, so by default, if you don't specify block size on Hadoop, by default, it is 64 MB on all the blocks on the system. So basically all data nodes will store 64 MB blocks. So Fani is saying, can you come again? What exactly FS image contains and edit log contains? What is the default file size of FS image and edit log when we set up the name node? Yeah, so default file system size would be like very tiny because initially you don't have anything on your file system image. So again, once I show the demo today, you will see that initially file system image would be like few bytes because there would be nothing in file system image. So as and when you start adding nodes, the file system image will be built up, and then we discussed yesterday that secondary name node does some checkpointing. So when I said that at any point of time, if you want to see the state of your file system image, you basically combine initial file system image with the edit logs. So this combination, this merging of file system image with edit logs is done by secondary name node. So again, in our further sessions, we'll see how secondary name node does it. So basically, that's why I said that FS image is like constantly, if your secondary name node is running, it will constantly update that file system image by merging the edit logs at a point of time. And then those file system image will actually, if your secondary name node is running, your file system image size will keep on changing every hour, because what secondary name node will do is it will take the original file system image, take all the edit logs that happen in 1 hour, merge them together, and send the new file system image to name node, and then name node will start using that file system image, and all the edit logs that happen after are written in the new edit log. So every hour secondary name node does this thing. It will merges file system image with the edit logs and give it back to the name node. So that's why at any point of time, if you want to see real file system state, you have to use the file system image present on the name node plus the edit logs, because edit logs have all the deletes, the new mkdirs, all the new directory creations, also all kind of transactions, they go in edit logs. So hopefully that answers your question, Fanny. And so Fanny is saying, so it's like the data file and log file in SQL Server. Yeah, so it's like bin logs, right? So you have the transactional logs. So it's like that. So basically FS image is like file system image that initially comes up. So Sanjay is saying, when is edit log synced with FS image? So Sanjay, as I just explained this to Fanny, so I hopefully that answers your question, that every hour secondary name node is going to take file system image and take edit logs at a particular point of time or a transaction ID, and it marks that transaction ID that I have taken edit log till this transaction ID. So edit log basically has a transaction ID. So secondary name node will combine file system image and edit logs and send it back to name node, and then name node will use this new file system image, and then all the edit logs starting from the transaction ID till that the point where secondary name node has basically merged. So next time secondary name node will start looking at the edit logs from that new transaction ID that it saved at last hour. So that's how this merging happens. And again, we are going to cover it detail when we discuss secondary name node. And then we'll look at the HDFS architecture. We also briefly discussed this yesterday. So we are saying that client is the machine from where you are running Hadoop commands, file system commands to name node. So all the metadata operations to read data, write data happen from client, and client contacts name node. Name node is storing the metadata, which means all the files, and knows what is the replication of each file and what are the blocks made up of each for each file, and knows which data nodes have those blocks, and data nodes are basically storing the blocks, and replication happens across the data nodes based on the replication factor you have defined. And then you have multiple racks, so you might have one rack having few data nodes, second rack having few data nodes. So again, rack awareness is something we are going to discuss in today's class. So for your questions, rack awareness I'm going to discuss again. And Then so whenever client needs to read, basically it goes to name node, and it basically gets the location of data nodes and read the nodes, the blocks from data nodes directly without talking to the name node. Similarly, when a client has to write, it basically talks to name node, gets the location, and starts writing the blocks to the data nodes directly without contacting the name node. So name node just tells them this is the nodes where you should write the data, this is the nodes you should read from the data, and then name nodes part is over, because otherwise name node will be a bottleneck for everything. Everything goes through name node. So that's why name node just tells the location of blocks, and then clients, they talk directly to the data nodes to read or write the data. Okay. So Mohammed is saying, can we change time of syncing? Yes. So by default, it is 1 hour, but you can definitely change it. Yes. So Hadoop is very configurable in terms of allowing you to change the parameters. So this is how basically HDFS blocks look like. So I explained the FS image. And then I explained about edit logs, and then I explained about a bitmap, right? So what I said was name node has a list of files, and name node has list of blocks per file, and name node has list of data nodes per block. So that's the bitmap that stays in memory. So the list of files is basically file system image, and the list of blocks per file is also in file system image. Edit logs are the real edits happening to the file system, which means deletion of a directory, addition of a directory. So those are edit logs. And other than that, what are the number of list of data nodes per block? So every block based on replication factor will have certain number of certain data nodes where the data would be written, right? So one block has 3 data nodes, because that block based on replication factor, there will be 3 data nodes that will basically having the copy of that block. So this is basically the memory part of metadata that stays in name node memory, that what is the list of data nodes per block. So that's basically comprising the name node metadata. So Mani is saying, when name node is recovering from a data node crash, will there be any impact to the availability? No, because we have a replication factor, right? So even if once a data node went down, name node will still have in memory that this block has these 2 data nodes where it is available. So whenever a request comes to read that block, name node will not use the data node that has gone down, because it has already updated its bitmap, and it will just go to the next available data node, and that data node will have the block, and client will read directly from that block, from that data node. So if a data node is down, it does not impact clusters availability, and people can still read and write the files. So that's basically the main beauty of Hadoop, that even if your few nodes are down, your cluster should still be able to operate, and people should still be able to read and write the data without waiting for that node to come up. So Sanjay is saying, how does name node decide which data node to pick from 3 replicated nodes? So basically, name node will just basically has that algorithm that it will write that this block has these 3 data nodes. So if you have no rack awareness, it could be in any order. So when we have rack awareness, then name node decides in a particular order that we'll discuss in the coming few slides. So Sanjay, that would answer your question, that how name node will decide which data node to pick to write and to tell the client. So while has a question, if a task tracker is running on a data node that went down, what happens to the task tracker? So basically, if we say that data node process went down, that means just the JVM for data node went down. That means the host where data node and task tracker were running, then that host is still up and data node went down for some reason, then the task tracker would not be impacted, right? Because data node is a separate Java process and task tracker is a different JVM. So if data node went down, it doesn't impact task tracker. But if say your host went out of memory, in that case, the host is just not up. So in that case, both data node as well as task tracker, both of them would be down. So hopefully that answers your question well. So the thing, what process is writing the data block? So I guess Sumiti, in our next slide will answer that question. So let's go to our next slide. Anatomy of a file, right? So let's see how a file is written to Hadoop. So you can see this is like a flow diagram that has basically points which tells how exactly is things happening. So if you look at this diagram, we have HDFS client, which we are again saying the machine from where you are basically running Hadoop commands. And then you have a distributed file system, which is Hadoop Distributed File System. And then you have name node and the data nodes. So first step would be that your data node is basically going to uh, talk to name node and say that I want to write something, right? So it will just write a tell data node a create Java basically command, which on the background would be a Java API, and it will say I want to create a file. So that create call goes to name node, and what name node will do is it has in memory the bitmap, and it has what all blocks are on what data nodes and how much space data nodes have available. So in the name node will then it give him a list of 3 data nodes or 5 data nodes based on the replication factor. If replication factor is 3, it will provide 3 data nodes to that client, and if it is 5, it will tell it 5 data nodes. So what happened in this case is the HDFS client will now get the list of the nodes, and then client will now, so that would be step 2, and then at step 3rd, now the client has the list of data nodes and it starts talking directly to the Hadoop distributed file system, which basically are these data nodes. So at steps 3, it will start talking to the data node and contact the first data node in the list, and it will go to the data node 1, and data node 1 will basically start reading that packet, and it knows that it has the rest 2 data nodes also where it needs to be written. So it will start writing the data, and it will inform the next data node that this packet is coming up, so you write this packet, and that next data node will again see that there's another data node that needs to write this block, so it will start writing this block and tell the next data node that okay, you also write this block because you are also supposed to write. So you can see that this is now a pipeline where all the 3 data nodes that client is trying to write to, it contacts the first one, that first data node then contacts the second one contacts the third one. So this is called a pipeline write, that when you write the data, it is like a pipeline, it goes in a pipeline, and once the last data node is done, it will give an tell this data node that I am done. This data node will tell I'm done. So now at this point of time, all the 3 blocks are written, and then they will basically send an ACK back to the client that we are done. So this client will now know that I am done. So it will then close this session with this file system to talking to the data nodes, and then it will send a message to name node that I am done, and name node will basically get updates from this data nodes also that they have new blocks, because data nodes periodically send the block information to name node. So whenever they write basically a file, they will tell name node, and then name node will then say that okay, now your create command is completed, and then the client will get the success back. So basically this is how a file system, how a file is written on Hadoop. So let's see what questions do we have on this. If no questions, I'm assuming everybody understood it. If everybody understood it, that's really great. Okay, so there's a question by Ryan. Does it mean that we'll never lose data on a Hadoop cluster unless the name nodes are down? Because even if the 3 data nodes that a block is replicated across are down, the name node will start replicating again. Is my understanding correct? So basically what we are saying is that Ryan, so what we are saying is, so your Ryan's question is, does that mean that we will never lose data on a Hadoop cluster if the unless the name node is down? That's true. But the second point that you are saying is, if 3 data nodes that a block is replicated across are down, the name node will start replicating again. Is my understanding correct? No. So if all the 3 data nodes where the block is basically present, and all those 3 data nodes are down, in that case name node and your replication factor is 3, that means only those 3 data nodes had that copy. In that case, name node does not have any place or any copy to replicate it from, because all the 3 nodes are not present, right? So in that case, the data is missing. So basically that's why your the copies of data is based on your replication factor. So if you lose one data node, 2 data nodes, it's fine. So you still have 1 copy, and then name node can replicate it and make 3 copies. But if all the 3 data nodes are down, then name node is not going to be able to replicate it, and at that point of time it will be the missing block. And when the file read, or when some client tries to read that file, it will get an error that missing blocks or the data is not available. So that's how it happens. So name node can replicate only if at least one replicated copy is there. If no copies are there, then at that point the data loss has happened. Basically, till the time you don't bring those data nodes up, you won't be able to access that data. So Sanjay is saying a write request is also sent by client, right? So basically your file system is just a file system, right? It is looking at, it's doing its own thing of storing the data, telling name node. So basically your file system are all the number of data nodes in your system. They make your file system, and name node is basically looking at the state of the system. Data nodes are telling name node what blocks are. So they're just doing their own thing. So unless somebody wants to get some information out of them, they are not going to do anything. If only if a client wants to read or write data, that's only action will happen, that they will contact name node to write the data. Then name node will see, okay, I have these nodes available where data can go, and it will give those locations to client. So a write or read request or a job submission will always be done by a client, because name node is a server, and similarly job tracker is a server. So Shama is saying in this example, where is split happening? So Shama, split is not happening in this question. Split comes into picture only when you run a job. So right now we are just talking about reading and writing data, which is HDFS component of Hadoop. So when we discuss about MapReduce component, only then splits basically will come up. So splits will happen on basically when you say write a file and you copied 3 blocks. So those 3 blocks will become 3 splits, input splits for the job when you run against this file, and those 3 splits will basically run 3 mappers. So when we discuss our MapReduce engine in detail, that's when we'll discuss that how splits are happening. So Fani saying, so looks like client to name node, and name nodes given the data node details. Client contacts job tracker with data node details to write. So there's no role of job tracker. So that's what I just explained, Shama. So when you, whatever you see on this screen is exactly the components which are the players. So there is name node and data nodes, and there is client. So there is no job tracker. When name node provides a list of data nodes, this client will go directly to those data nodes, which is in number 4th. It is trying to write that packet. So this client is directly talking to those data nodes. There is no job tracker in between, because job tracker is only for jobs. Right now we are not running a job, we are just writing a file. And so job tracker component, Fani, you can keep separate. We'll discuss that, how job tracker will do this. Right now we're just talking about when data comes to Hadoop, how do you basically write data. So this is basically HDFS client. When you run, say, job, so this client, if you are submitting jobs from this client, then it would be called like a MapReduce client. So I was just looking at Fani's messages. So she's talking about job tracker. So I just explaining, as I just explained her, that job tracker is not in picture right now. Right now it's only name node, data nodes, and the client, which is HDFS client. So Sumati is saying HDFS client here is HBase client. No, again, let's not confuse anything else. Right now, we are just talking about name node, data nodes, and a client, which is just trying to write or read a file. Nothing else is happening right now. So right now, we're just talking about how Hadoop distributed file system works. So once we understand this, then we are going to go to job tracker, Hive, HBase. Right now, we can basically think just about this particular scenario where we are trying to write a file and try to understand this. So we'll come back to all of these things as we progress on the rest of the things. So Shripal is saying which component determines the data nodes, that is where the data should go. So that's name node, because when the data nodes initially come up, they send their block report to name node, and name node knows the cluster capacity, and it knows how much capacity each data node has. So name node decides that which data node would be able to handle this file, and it will just, it's on based on its internal algorithm. Whenever a request comes, it does that, and it sends the list of data nodes to the client. So Shama is saying when the file size is more than 65 GB, then who is creating block? So when a file size is more than 65 GB, so when you say 65 GB, that means it will be split into blocks of 64 MB. So what you can do is divide 65 GB by 64. So that's like almost 1000 blocks, right? So those 1000 blocks now, again, even if it's 3 blocks or 50 blocks or 1000 blocks, the same process happens. Name node will tell the client that these are the 10,000 blocks that you should write, and then the client will basically go directly to the data node and write those blocks. So if a file has say 3 blocks, so each block based on replication factor, it will write them the client will basically write them in a sequential way. And if it has three blocks, similarly, this is like first block and it is being replicated to three data nodes. Similarly, there will be a second block and it will be replicated three times. So basically, writing all those three blocks can happen in parallel, but replication of each block will be sequential. So this is how basically it works, because so that client can basically write the file quickly. If a file is basically made up of three blocks, the name node will tell first block should go to these three data nodes, second block should go to these three data nodes, third block should go to these three data nodes. So when client tries to write, it will try to write all these three blocks in parallel, but replication of each would be a pipeline write, as we see in this figure, that each blocks writing of each block would be a sequential process. So Fani is saying, so a client has permission directly to write to data to DFS. Yes, a client will be able to write directly to DFS, basically, because name node does not do that. Because if client sends data to name node and then name node writes, you can see that how much network bandwidth will be used. Because then you say you're writing a 50 MB file, you first of all, client will send that 50 MB file to name node, then name node will write them to data node. So there's a lot of network movement, so we don't want that. So and then name node becomes a bottleneck, because name node has to serve multiple clients and multiple requests. If we start just moving this 50 GB data, somebody else would come with another 200 GB data. So name node would just be moving data around and not doing the real work, and it will become a bottleneck. So that's why name node does not move any data. It will just tell the list of blocks, and the client will write to those blocks directly. It's client's responsibility. So Mohammed is saying, who should be in right should be in opposite direction. Opposite direction means, Mohammed, I couldn't understand. Okay, so Fani, do you still have confusions? It looks like you have some more questions. Yeah, looks like I was saying you she, but I'm wrong. I'm sorry about that. And Varun is saying, doesn't the files can be run by jobs, by the bad jobs? Doesn't the file can be run by bad jobs? I'm not sure what you mean by that. So, so right now we are just discussing that, okay, when a file run comes to name node, how name node does. But if you have, say, a batch process like a cron tab or something, which is constantly writing the files, so this process will be done for each such file. So we are just telling how a file writing of a file happens on name node, and your process might be doing a cron tab, it might be uploading files directly on HDFS. So for each of the files, basically writing of each of those files, this kind of process happens. Mohammed, you have a question. All right, so let me come back to your question. um, a client could also be a command like copy. A client, basically we are saying, is like a machine from where you are basically writing your Java code to write the files or run the files. You can say Hadoop FS put the file on HDFS. So that basically is a Hadoop client which invokes this Java APIs to write the file. So that's, we are saying, is basically a client. It could be a command like copy. Yes, that's correct. And it could be a Java program. It could be basically a Java program, or it could be a shell script which is writing the data to HDFS. So those all basically, the any process basically which basically calls Hadoop file system APIs to write and read data is called as an HDFS client. So Krishna has a question that if a 128 MB file will be split into 264 MB while writing, that's correct. So split is involved. So split, okay, so when you say splitting of a file, that's correct. The file is split into two blocks. But when we talk in Hadoop, when we say splits in Hadoop, it means basically in relation to a job. So in jobs, all the blocks that are present for an input directory or input files, whatever blocks are present in those input files, those blocks, they become input splits of a job. So that's basically just a terminology. So Krishna, you are right that a 128 MB file would be split into two blocks, and those two blocks will be replicated into the times the replication factor. So split happens, yes, but the real split in terms of Hadoop is used in a job running perspective, where you say that the data is the input data is split into those blocks, and those blocks are called the input splits for a job. So it's just a terminology. Yeah, so you are also right. So Praveen is saying, what is the criteria for identifying the data nodes by the name node? So that's the name node algorithm. So it basically looks at the disk space available, and so if data node has say 5 drives, so it will see in round robin fashion that which of those drives have space available, and it will basically tell the client to use that data node. So it's in a round robin fashion. So Praveen has, what is the criteria for name? Praveen has a question. What is the criteria for identifying the data nodes by the name node for a file? So which we just discussed. So Mohammed saying is, what is the maximum block size that could be configured? So Mohammed, we just had this question yesterday also. So maximum block size depends on the so the block size is defined as an integer on Hadoop system. So maximum block size could be based on integer limit is 2 GB, but mostly you will see nobody would do a 2 GB block size, because it's basically waste the files, because when your files go to Hadoop system, every file would not be a 2 GB file, so you'll basically be wasting your space on HDFS. So that's why people go by 64 or 128 MB. So name node, Mohammed saying name node tells client APIs. Sorry about that. So name node tells client IP of data node or host name. So basically name node will tell IP or so it basically depends on it is. So mostly you will see that people, when they basically configure their Hadoop cluster, they set up a DNS, or they will basically have the host name configured. So it can tell IP or host name. So mostly it would be IP. So Narayan is saying, is there a console where we can see what are the allocated occupied space memory on each node? Right. So once we do our cluster setup today, we are going to look at that console also. So Muhammad is saying, how do client know name node identification of data node? So client does not need to know name node identification, because client just wants to write data, right? So it just needs space where it wants to write the data. So name node will identify the space where the blocks and the data nodes, basically where those should go, and it will just tell those blocks to the client, and client will just directly contact those data nodes and write the blocks. So basically a client does not need to know how name node has identified the data node. It will just gets the list of data nodes, and it will just write those blocks to those data nodes. So one was saying, how can name node calculate the size of a file? So based on your block size. So if your file size is say 128 MB, your block size is 64 MB, right? So name node will basically look at the file that is coming, and it will basically divide it by the block size, and then calculate the number of blocks, and then decide which block should go on which data nodes. Okay, so Shripal is saying, where does DFS run? Is that the one on the client machine? So basically, Shripal, as I just discussed, that distributed file system is all the nodes in your cluster. So all these 3 nodes that you are saying, so these 3 nodes basically make distributed file system. This big box basically means these data nodes, these 3 data nodes plus all the other data nodes that are present in your system. They all basically combine together, and they form the distributed file system. And Jagdish saying, who will create the files? It is Hadoop admin's responsibility. So Jagadish is saying, who is going to create files? It is Hadoop admin responsibility. It could be anybody who is creating the files. As you might have 10 people who are basically 10 different teams who are writing data to Hadoop. So those teams are basically writing the files, and they could be just some users, or it could be Hadoop admin also. If those users don't know and they want Hadoop admin to basically upload data to HDFS every hour or every few hours, then it would be Hadoop admin. So it would be some users basically who would be writing the files, or it could be an automated process that runs every hour and gets data from somewhere and writes it to HDFS. So Sanjay is saying, if my file is 65 MB and contains one record, is it going to be split into 2 blocks? No. So if your so if your block size is 64 MB and your file is 65 MB, then yes, it will be split into 2 blocks, because block size is 64 MB and your file is 65. So 1 MB is still left, and name node cannot basically just leave that 1 MB. So that 1 MB goes in another 64 MB block. So basically you are wasting the space in that block, but that's how it is. So that's why we say that on Hadoop, you should not write a lot of small files, because your block size is big, 64 MB. If your file is say 1 MB, then the space of 63 MB is just wasted. Okay. So Shama is saying, is the DFS creating blocks? So DFS is not creating blocks, right? So HDFS client is basically telling the data node to create blocks. So HDFS client will send the information, the block information, and data node will be the process which is going to store that block on its local disk system. So data nodes are basically storing the blocks, and HDFS client will just tell that, okay, I want to write this file. So data node will basically write the block that it is supposed to write and store it in its local files, local storage. So data node will basically write the blocks. So Shiva is what is the response from the name node after 2? So after 2, basically name node tells the client that these are the list of blocks. These are a list of data nodes that you should contact for each block. So then the client at number 3 will start writing to the file system for each of the blocks available. So number 3 basically signifies the writing of the blocks to the data nodes, and the write would be a pipeline node, pipeline write, as explained in this diagram underneath with the 3 green data nodes. So Shreepal is saying unique file system is part of OS code base. So where is the code binaries for HDF for DFS? So basically, that's again something once we do installation, I think it will be more clear. When we install Hadoop, every node will basically have a directory where Hadoop binaries are installed. And when they are started, they are provided a class path of those binaries. And that's where they will basically going to read all the jars. A data node will know, data node daemon will know where its libraries are, name node will know where its libraries are, task tracker will know where its libraries are. So once we start today, I'll show you. So Fani is saying, in this process, does data node contact name node directly stating they completing the data right? Yes. So data node periodically send their block report to name node. So they will basically also tell the name node that my block is complete. So Fani is saying, if she has a 200 MB file, it splits into 64 plus 64 plus 64 plus 8, right? That means 4 blocks. In case 4 blocks is wasted for rest of 56 MB. Yes. So if your file is not aligning on the block boundary, then you are going to basically waste the blocks. Yes. Okay, so hopefully the write is a bit clear. So we had a lot of Q&A on this, I guess, so it should be clear to everybody. So let's go to our next slide, which again just tells the same thing, that what is a pipeline write, that you are basically the name client, the HDFS client is basically asking name node to add the blocks, and then it gets the block location back and it starts to write, and write happens as a pipeline where data node will basically get the block and it will start writing it, and then and it's also tell the next data node, and that data node will start writing the block and it will tell the next data node, and then once they are done, they will just send their block information back to name node, and once all these 3 data nodes are done, this data pipeline is done, they will send the act back to the HDFS client. So Sumati Singh, is there an integrity check? So yeah, that's as a part of write, basically those APIs, they do all those checks, right? How so Shreepal is saying, how is failover handled in a pipeline write sequence? So if a failover happens in this case, then this basically the failover, if the data node, say for example, fails, then client is basically going to get a response back that the process is not able to write, and that write will fail. So in that case, client will have to basically contact name node again to get the new list of data nodes. So for example, if it was writing the first data node and this data node went down, so then the process cannot be finished. So this client will basically get an error response back that could not contact data node, or not able to connect to that data node. So in that case, the write will fail because it was not able to contact the data node, and then it will basically have to contact name node again to get a new list of data nodes where it can write. All right, so hopefully pipeline write is available. So this is again another explanation of this replication. So what we are saying is that name node is going to basically store metadata, which means every file's blocks it will decide, and it knows the overall file directory structure, and it knows where the data block is placed. So if say this user dug hinfo file, there was a file and it had blocks 1, 3, and 5. So and replication factor is 3. So one block is replicated on this data node, this data node, and this data node. So basically there are 3 copies. Similarly for 3, there are 3 copies. So based on replication factor, there will be 3 copies done for each basically block. And then we have a concept of rack awareness. So there's another question by Shripal before that. What would happen to previous write blocks? So let's go back to this thing. So for example, data node failed in the second, say, state where second write. So in that case, because this is a pipeline, so when this fails, this data node tells back to this data node that I have failed. So this big data node will just relay that message back to the client and say that we could not complete this write because this data node failed. And then this data node basically write call has failed, and it will have to basically handle that failure by either rewriting the file or somehow it has to basically rerun that process. So it all now depends on the client whether it want to rerun or not rerun. But if a data node has failed, then that write basically will fail. So more thing, what are the different replication factors, and explain explanation 1 and 2, and do we have 4 also? Okay, so let's go back to our replication screen. So replication factor, as I explained yesterday also and today, that by default it is 3. So if you are, so for example, user Doug Info has block 1, 3, and 5. So it has 3 blocks. So block 1 will be present on 3 data nodes at any point of times, which is data node 2 in our case, data node 3, and data node 4. And block 3 is available on data node 1, data node 3, and data node 4. So you can see that every block is basically copied 3 times based on the replication factor. If your replication factor is 1, then it will be just on one data node, nowhere else. So that's how basically replication happens, that all the blocks a file is comprised of, name node will make 3 copies of each block. If this hinfo had 1, 3, and 5, there will be 3 copies of each of these blocks. That's all replication means. So Mohammed is saying, what are the different replication factors? Play replication 1 and 2, and do we have 4 also? Mohammed, I could not understand the question. So Mohammad's question is, what are different replication factors? So Mohammed, replication factor is something that you configure. By default, it is 3. You can make it 1, 2, 3, 4, 5, 6 based on what you think is a good configuration for your cluster. But most companies leave it 3 because 3 is a good factor. Because beyond 3, then you are going to make 4 copies of the data, and then your cluster capacity basically decreases because you are now saving more data for just same file. So that's why replication factor is usually kept as 3 in most production systems. You can make it 1 or 2 or 4 also based on the space that you have in your cluster.